Hello and welcome. My name is Cameron Stewart, and today we're going to do something different. We're going to do some design in Aurora. Now, Aurora Solar has made themselves one of the premier tools for design and proposals, and I just want to show you how best to use SolarEdge products in this Aurora design tool. So I've already created a new project. I'm going to go ahead and put in my address of 836 South Oakstone, which is a address in Anaheim, California that we've done many designs on before, and I just kind of want to show you how best to use Aurora. So we'll call this the SolarEdge design. Okay, so first things when you're using design mode in Aurora is we really want to understand, especially in NEM3, Southern California Edison, what our consumption profile looks like. So I'm going to put in for July, I have 1 month here, and it's 1536 for kilowatt hours usage in July, which yields about 15 megawatt hours annually. All right, so now let's get into our designs, and we're going to create a new design. Okay, so here's our roof, and you can see that it has absolutely no shade, which is fantastic. I want to take advantage of the Aurora AI Smart Roof, and they're going to do all the hard work for me and create all the edges and roof lines and a 3D model of the roof. So fantastic. We have a beautiful 3D model, and it was over that fast. Very easy, very efficient. Good job, Aurora. Okay, now I want to place some solar panels, and I'm going to first, before I put solar panels down, I want to add my fire walkways, so that way I'm adherent to the fire code. All right, now Aurora places these fire walkways based on irradiance, and they try to leave you the most open areas for solar production. Okay, so now I'm going to place my solar panels. And lately I've been using these Trina 450s, and I'm going to put them on a landscape orientation, and I'm going to just fill the roof facet. So I want to build on this roof, this roof, this roof, and that roof. Okay, let's go ahead and escape. Now, I'm going to run a quick simulation for the system to get a rough production estimate. Now, we know in California NEM3 that we're not allowed to produce more than 150% of our consumption. Now, our consumption was roughly 15 megawatt hours. So let's take a look at what our production is, and we're already at a 200%. So we have to reduce this. Right now, it's at 31 megawatt hours. So we have to reduce the number of panels on this roof. What I typically like to do is I like to have a conversation and say, okay, which panels are meaningful to the homeowner? Do they want to keep what is meaningful to my installers and easy to install? Some homeowners don't like solar panels on the front of their roof. Now, in this case, this is the west face, and these solar panels would be the best opportunity for high price offset and production in the on peak time, which is what we want. So I'm actually more likely to move these east facing modules so we can take advantage of our power hours. So now that we have a good idea of how many modules we have, let's run a simulation again, and we need to get this number below 150% for our interconnection agreement. Oh, we're so close. We're at 155. So I'm just going to drop a couple more modules just to make my life a little bit easier. Okay, there we go. Let's simulate this. All right, so now we want to know what the actual simulation results look like. What happens when you add a PV inverter? Now, here's a funny thing that, I work with Aurora a lot, that not a lot of people realize. When you run a simulation without an inverter attached or strung in particular, your simulation results are basically based on a generic inverter at a 96% efficiency, no module level power electronics. So it's a good estimation, but not the actual production. So what I like to do is I then like to run auto stringer and select my inverter. So we're going to run auto stringer. We're going to select our SolarEdge inverter. Now we have new inverters with domestic content, and there's going to be another video, probably a link right here, where you can check out how to manage your Aurora database. But I'm going to pick this SolarEdge SE1100 USA, that's domestic content, and then the 2024, fantastic. And it's the Aurora tool's like, hey, you have to use this with power optimizers. I'm going to use the USA domestic content, the U650 power optimizer in a 1-to-1 application, and we're going to run auto stringer. Now, SolarEdge design tool has the most updated design rules and requirements, and this is pretty good. You know, SolarEdge does allow you to mix azimuths like this. Let's see if we can clean this up for an installation. You know, as an installer, I generally try not to have jumpers go back and forth across the roof if I can avoid it. But, you know, sometimes you can't. So I'm going to delete these strings. I'm going to show you what I would do for just a manual string. And let's see if we can clean this up. All right, so here's my string. We're going to go to manual string. And I like exactly what Aurora did with this one. So this roof facet, this west face was perfect. That's what I would do. 11 solar panels right there. And then we're going to run this one. And we're going to attach all of these solar panels right here. So that's string 2. And then maybe even a third string over here. And of course, if you wanted to, you might get away with 2 strings. No, just outside of 2 strings. I think 13, looks like about 13 modules is going to be your maximum. Okay, so here is a 3-string design using the Aurora design tool, and you can't forget to attach these strings to the inverter. That does impact the simulation. So let's go ahead and attach those to the inverter. And I know it's giving me an error, but it's not actually an error. So let's go ahead and simulate. Okay, so we see this 140% production. I'm betting that this is going to go up because, yep, 145% production, because SolarEdge gives you not only module level power electronics, which mitigates module mismatch. You can see here we have 0% on our module mismatch, but it's going to produce more energy over the lifetime of the system. So this energy is 22 megawatt hours, 22.5 megawatt hours. Now, a critical aspect of designing systems in California is storage. Now, you have to add energy storage. So I'm going to select our SolarEdge battery. And a funny thing in the design tool in Aurora is you also have to choose an inverter because it's a DC coupled battery. So they're like, hey, what kind of inverter are you putting on? But that's not going to add any materials to your bill of materials. And then we're going to run this in an energy arbitrage. And we can run a simulation on what this looks like. In general, I'm going to say you need 2 batteries. And again, just a funny thing for the Aurora design tool is every time you add a battery, it's going to add an inverter, and that's how it stacks its capacity and output. But you can stack up to 3 batteries per single inverter and have that power output stack until it reaches the AC nameplate of the inverter. But in this case, we have an 11.4 kilowatt inverter, and if we had 2 batteries, you'd have 10 kilowatts. So just don't be afraid when you see this happen. It's just kind of a nuance in the Aurora tool. And I'm working, of course, with Aurora to help them represent our product correctly. Okay, so here's what we wanted to see. Absolutely. So if you were to do solar only on this job, the customer is going to see still a monthly bill of $191 because you're not getting true net metering anymore. Your value for your net metering is so drastically reduced. So what we always need to do in NEM 3 is add batteries. And in this instance, solar plus battery, this homeowner is only going to have to pay $15.60 a month. So that's what we would like to see. And that concludes how to design a system in the Aurora tool. Thank you so much for your time and attention, and please stay tuned for more SolarEdge videos.